Here's question number 2. Particle P is moving along the x-axis. The velocity is given by that equation from 0 to pi. And at time t equals 0, the particle is at this position. So hopefully this is a more comfortable question than number 1 that we did yesterday. Understanding velocity and acceleration. And then there's a second particle Q, and there's information about the velocity of it and its position. So it says find the positions of particle P and Q at time t equals 1. So how do you find that position? So you start with the position we're starting with. So for P, we're starting at 5. And then we integrate. So we start at 5, and it's at 5 with 0, so we start with 0. And then it wants to know at time 1. So it goes from 0 to 1, and you do the velocity of that. Now you're going to use your calculator. So use your calculator, type it all in. And the answer you should get is 5.370. The particle for Q starts at position 10 at 0. So we start with 10. We integrate from 0 to 1. And then for Q, it's t minus 1.8 times 1.25 to the t. Type that in your calculator, press pause, and see if you get the same answer as I get. And it should be 8.564. All right, that was part A. Part B, not too bad. Are particles P and Q moving towards each other or away from each other at time t equals 1? And explain your reasoning. So I need to understand, first of all, the velocity of P at 1. So it means I got to use my calculator again. Plug in 1. And the velocity of Q at 1. So I just plug 1 in for t, use my calculator, and see what the answer is. And I'm interested to know if the answer is positive or negative for the velocity for both, because that's going to give me the direction at 1. So for the first one, the answer is positive. So it's good to know that this at 1 is greater than 0. For the second one, the answer is negative. So the velocity of Q at 1 is less than 0. So what does that tell you about the direction of what if they're going towards each other? Well, we need to know where they are located. So Q, if I think of a number line here, here's at 8.564. There's Q, and it's negative. So it's going left. Particle P is at 5.370. And the direction it's going is to the right. So are those particles coming together, or are they going apart? So P and Q are moving towards each other. So to understand if they're moving towards each other or away, we need to know its velocity, so you know what direction it's going, and we need to know the position. So we know the position and direction. Put it on a number line so you can see what direction they're going, if they're going towards each other or away. All right, part C. In part C, find the acceleration of Q at 1. Okay? So the acceleration is the derivative Now, I'm not going to do this by hand. I'll use my calculator for that, but I'm going to take the derivative of this at 1. So if you take the derivative of that with your calculator, so again, if we need support with that, so the beginning of the question, the best thing you could have done is to define it. So if you already have something in there, you can erase it. And I would have actually done both. So I would have done sine, and then I have to use x to the exponent 1.5. And then the second one, and I don't care right now about the graph as much. The second one would be parentheses x subtract 1.8 times 1.25 to the exponent x. Make sure I typed it in right. And now they're both in there, so that when I come here and I want to take the derivative at a point, I can do that. It's also easier then to evaluate. So if I want to know what the velocity is, I could just plug in 1 into the first one and say, oh, that velocity is 0.841, right? That's what that one was. Or for the second one, if I want to find the velocity at 2, oops, same thing, right? And you can see the answer is -1. So that would be simple. If I want to integrate this with the calculator, since it's defined already, I can just go 5 plus, and then menu calculus integrate, and again it would go from 0 to 1. Instead of typing all that in, oops. And then you have your answer, right? That's what that was, 5.370. Same thing here, you can go 10 plus, again, menu calculus integrate from 0 to 1. And then the second one, F2 is the second particle. And it just makes it easier, just have to type it in once and then you have your answer. So for this one, I want to take the derivative at 1. So I'm going to go menu, calculus, derivative at a value. And then I'm going to plug in what I'm looking for. For this, the derivative at 1. And it's of Q, which is the second particle. So for the second particle, then, the answer is, let me check the answer key, make sure we're together on this. Yeah, 1.026 or 7. So there's the acceleration. Then the second part is the speed increasing or decreasing? So to understand that, I have to look at both the acceleration and the velocity and see if the signs match. So the velocity at 1 was -1. So notice one's positive and one's negative. That means the speed is decreasing at t equals 1. And the reason it's decreasing is because the acceleration is positive and the velocity is negative. You could even write those words down. The acceleration is positive at t equals 1 and the velocity is negative at t equals 1. So if you don't like the symbols, write out the words so that you can say what it is. All right, part D. Last part. Find the total distance of P over the time from 0 to pi. So like if I look at this honestly, like question number 2 has lots of points to be had. That's an integration question from 0 to pi. It's the absolute value of velocity. That's the part we need to remember. So it's the absolute value of this, and then type it in and be done. So the first one was kind of awkward, but the second one had lots of points to it. So this question here was an easier question to do. So we're going to go menu. We're going to go calculus, integrate. Again, we're going to go from 0 to pi. And then that's the first particle, P. Oh, what did I forget? I forgot the bars. So press the button beside the 9 and then press the absolute value bars. Now type in F1 at x, dx, and then what's the total distance? And you get 1.9. And again, I'm going to double check to make sure. So 1.931. And that's it. All right, so I hope you used your calculator, you practice with me, you try it first, and even if you don't, you go back and make sure you understand what's happening. All right, Mr. G Math, over and out. Till next time.